In this video, you will learn how to implement caching in your Spring Boot applications. So first of all, we will start off with understanding why do we need caching and what exactly is caching. And then we will see what is Redis and then what is the significance of using Redis in your applications. We will download and install Redis in your machine using Docker. And then we will go ahead and implement caching in a sample Spring Boot application. And finally, we will also write integration tests to test the Redis cache functionality for our sample application. So without any further delay, let's start the video. All right, so now let's first understand why do we need caching and what exactly is caching. So imagine that you have an e-commerce, we have an e-commerce application, and under the e-commerce application, customers are visiting our product page, and the product page is served by this products endpoint, right? /products endpoint. So whenever a client is making a request to our application server to fetch the products, our application server will make a database call to get the products from the database, and it will return it as a response. So imagine that our application is running during a Black Friday sale or something, and we have multiple requests, thousands and millions of requests coming into our application server to view the products. And in this case, our application is making a lot of calls to the database. As database calls are resource intensive, usually if you make a lot of calls to the database, then the performance of your application will suffer, right? To find solution for this issue, we can use something called as a cache, where our application will first, so whenever we first receive a request to our application server, our application will get the products from the database, and it will also save the response from the database to the cache. So whenever the subsequent request comes into our application server, instead of calling the database to get the products, our application server will first do a lookup inside the cache to get the product from the cache, and if and only if the product is not existing in the cache, then we'll make a call to the database. So this is the concept of caching. Redis is one of the cache that is available for us. So Redis is actually called as a remote dictionary service, which is an in-memory database. And as I mentioned, is most widely used as a cache. It can also be used as a reliable database because it has the ability to store the data to the disk, and it also can also serve as a message broker. And Redis is designed to be extremely fast. It can increase the performance of your application a lot if you're not already using a cache like Redis. So this is a short introduction about Redis. So now let's go ahead and install Redis on our system. So for this, we need Docker installed on your machine. So I'm going to first go to Google and search for Redis Docker Hub, and I'm going to click on this Redis official image link coming from the Docker Hub. So if I'm going to click on it, and so this is the official page of Redis where we can find the Docker image. So I'm going to go to tags, and at the time of recording this video, so we're going to install the Redis version number 7.4.2. So I'm going to open a terminal, and I'm going to run docker pull redis 7.4.2. So as I mentioned before, you need to have Docker installed on your machine. You can just press enter, and this will download Redis version 7.4.2 to your machine. So once this is done, you can see so the Docker image is downloaded successfully. So as I mentioned before, we are going to implement caching for a sample Spring Boot application. So you can find the source code of the sample in this GitHub repository. I'm going to link this. I'm going to add the link for this GitHub repository in the description section, and also I will also add it in the pinned comment. The initial code base is situated in the branch called initial. So if I just go to the initial branch, you can find the actual code base. So make sure to check out this GitHub repository and go to the initial branch, and then you can go ahead and start coding alongside with me to implement caching in this particular Spring Boot application. All right, so now I've downloaded this source code onto my machine, and I opened the source code in IntelliJ IDEA. What I'm going to do now is I'm going to quickly browse through the source code, and I'm going to give a quick explanation of what this application is doing, and then we'll go ahead and implement caching in this application. We have our normal Spring Boot application Maven project. So in the source main Java folder, we have the Spring Boot Redis cache application. Nothing special here. It's just a plain old Spring Boot application main class. So inside the entity folder, we have our product class where we have 3 fields: ID, name, and price. The next thing we are going to check is a controller package. We have the product controller class, and inside this class we have the request mapping annotation. We are exposing the API and under the URL /API/product. So here we have our post mapping method, which is taking in a product DTO as input, and it's calling the create product method of the product service. So if I go inside the product DTO, it's actually a Java record, and it is taking the fields as ID, name, and price. So if I go back to the product controller, let's go to the create product method, and in here we are just mapping the product DTO to the product object, and then we are saving this object into the database using the product repository. So in the same way, we have the get product endpoint, so which is taking a product ID as a path variable, and it is passing this product ID to the get product method from the product service, and we are just looking up this product based on the product ID using the find by ID method of the product repository, and then we are mapping this product back to product ID and returning it back to the as response to the client. Similarly, we have the update product method, which is taking the product DTO as the input, and then we are first making sure that an existing product is already existing in our database using this product ID, and then we are mapping the new values coming in from the product DTO to the existing product and then saving it to the database. Finally, we have also the delete product method, where we are deleting the product by ID and we are providing the product ID here. So nothing special. This is actually a very simple CRUD application. So if I go into the resources folder, we have this application or properties file. Here also we have configuration. I forgot to mention that we are using H2 as an in-memory database. We have also the connection string details and also the database details inside the properties. And we are also making sure to log the SQL in our application. So that is sample application. So now let's go ahead and start to implement caching in our sample application. Okay, so the first thing I'm going to do is to update the pom.xml file. So I'm going to open the pom.xml and I'm going to scroll until I find the dependencies section here, and I'm going to add 2 dependencies. The first one is going to be the dependency for Spring Data Redis. So this is going to add the Redis functionality to our Redis capabilities to our Spring Boot application. And the next dependency is going to be of Spring Boot Docker Compose. So the Spring Boot Docker Compose dependency will make sure to run the Docker Compose file automatically as long as you follow the naming conventions. So I will just explain a bit more in detail how it is possible, how we can do this. Once this is done, I'm going to on the root project, I'm going to create a new file called compose.yaml. I'm going to type in here services, and I'm going to type in the service called Redis, and the image name for this Docker Compose file is going to be Redis 7.4.2, and I'm going to use the ports 6379 on my local, and also so I'm going to use the port 6379 and map it to the 6379 port running on the container. So I forgot to mention, once you have added these 2 dependencies, make sure to force IntelliJ to download the Maven dependencies. So you can do that by clicking on this Maven icon onto the top right corner. So I'm going to click on this, and Maven is going to synchronize these dependencies and synchronize these changes and download these 2 dependencies to your machine. So once this is done, I'm going to open the Spring Boot application. So the Spring Boot Redis cache application, and to enable caching in our application, we are going to add an annotation called enable caching, right? So this is important so that the caching related functionalities and all the auto configuration will kick in once we add this enable caching annotation, right? So once this is done, let's go to the resources folder, and we also here we need to add the connection string for Redis, and for that I can do that by typing spring.data.redis.host is going to be localhost, and spring.data.redis.port is going to be 6379. So these are anyway the default configuration. So I'm just going to define this just to be sure that we are consistent in the project. So as this is a local Docker container installation, we don't have a username and password. But if you are using Redis installation on cloud, or if you're using it in your job, you may also need to add a username and password properties. So you can do that by using the spring data.redis.username and spring data.redis.password fields. And lastly, I'm going to add another property here called spring.cache.type is going to be Redis. And the next thing we are going to do is we are going to do the configuration also in Java, because I prefer to use Java configuration instead of this application properties file configuration, because it gives us more flexibility to do more things. So I'm going to create a new class called as Redis config, and I'm going to create this inside a new package called config. So I'm just going to type config dot in front of the class name. So what it will do is it will create this Redis config class automatically inside the config package. So that's a small tip you can use, small IntelliJ tip you can use. So I'm going to add the configuration annotation on top of the Redis config class, and inside this Redis config I'm going to create a bean of type Redis cache manager, and I'm going to call this as cache manager, and is going to take in Redis connection factory. And inside this cache manager method, I'm going to first create the Redis cache configuration. So it's going to be Redis cache configuration dot default cache config, and here in the default cache config I'm going to first provide time to live. So usually in Redis we store the values in the form of key and value, and for these values we store in Redis cache we can provide expiration time called as time to live. So we can configure that time to live using this entry TTL method, and we can provide the duration, how much duration we want to have the expiration time. So it's going to be for us, if for our case, I'm going to provide the expiration time as of minutes, 10 minutes. So after adding the entry in the cache, this particular entry will be expired after 10 minutes. And I'm going to make sure that I disable caching the null values. So because we don't want to cache null values inside the cache, we're going to disable caching null values. And finally, we're also going to make sure to serialize the values inside the cache using a in a JSON format. So for that, we need to define a serializer. So I can do that by adding this method serialize values with, and I can use Jackson to JSON Redis serializer to do that. So I can configure that using this Redis serialization context dot serialization pair, and you can see that GitHub Copilot is already suggesting me the code which needs to be configured here. So this is going to be Redis serialization context dot serialization pair, and from serialization I'm going to use not use a generic Jackson to JSON Redis serialization, but just a Jackson to JSON Redis serialization object. And here we also have to provide the class name of the object that's going to be stored inside the cache. So in our case, as we are going to store the product DTO response inside the cache, I'm going to provide the class name of product DTO dot class. So I don't need to use the object here. So it's just going to be Jackson to JSON Redis serializer, and it's going to serialize the values of type product DTO. So this is the configuration we need to do for our cache. So I'm going to store this Redis cache configuration inside a new variable, and I'm going to go ahead and type in return Redis cache manager dot builder, and to the builder method I'm going to provide in the connection factory followed by the cache defaults method, which is going to take in the Redis cache configuration object. And finally, using this information, I'm going to build a Redis Cache Manager. And once this is done, we are free to go ahead and implement the actual caching logic inside our application. So this is not complex. So let me go to the product controller, and here we want to implement caching usually on the whenever we are updating a product. Like that means whenever we are creating a product and updating the product, we are going to add a value inside the cache. And whenever we are deleting the product, we are going to just evict this value from the cache, right? And whenever we are getting a product, we are just going to do a lookup inside the cache and get the response. So to implement this, I'm going to go inside first the create product method. On top of the create product method, I'm going to add an annotation called as cache put. So let's go inside this cache put annotation. And if you read the description, this is an annotation indicating that the method triggers a cache put operation. So it's going to take the return value of this method and it's going to add this value inside the cache. So to be able to implement it correctly, we need to provide some more information like the name of the cache. You can see that here there are different free attributes that are applicable for this cache put annotation. So we are going to use the value attribute to provide the name of the cache. So the cache name is going to be product cache. So as I mentioned before, the cache is going to be stored in the form of key value format. So the value is going to be product DTO, but we also need to provide the key of the entry inside the cache. So for that, I'm going to provide the attribute key equals, and here I'm going to make use of the Spring expression language, and I'm going to use hash result. And this result is a built-in variable that is pointing to the return type of this particular method. So what I'm going to do is I'm going to make use of the ID field of the product DTO as a key, right? So in this way we can make use of the result of the return value of this method, and we can make use of the ID as a key. So this is how we can use cache put annotation. I'm going to copy this particular annotation and use it also for the update product method. So in this way, so whenever we call the create product endpoint, so whenever the product is created and saved to the database, it's automatically added to the cache. So we don't need to manage the cache operations manually. And this is we can do this completely through annotation. So the next step is actually retrieving these values from the cache, right? So I can do that using the cacheable annotation. So this is also an annotation coming from the Spring Cache library. And here I'm going to provide the value as product underscore cache, and we are going to do a lookup inside the cache using a key. So in this case, the key is going to be product ID. So if it is finding this value, then it's going to just return the product DTO from the cache. And if the value is not existing in the cache, then only this particular logic is going to get executed. And lastly, we have the delete product method. So on top of this method, we have to add the cache evict annotation. So this will make sure to remove this particular entry from the cache. So also for this annotation, I'm going to provide the value as product underscore cache, and the key is going to be product ID. As you can see, implementing caching is actually pretty simple. It's using Spring Boot. Thanks to this annotation driven approach. We also have another approach where you can manually do the cache operations using the cache manager interface. So for example, I'm going to add the cache manager here. And what I can do is, after saving this entry inside the database, I can do cache manager dot get cache, and I can provide the product cache name. So what this will do is it will try to get the cache with the name of product cache, and if it is not existing, it will automatically create a cache for us with this particular name. So I can store this variable inside name called, I can store this return type using inside a variable called as of type cache. And here I can do product cache dot put saved product dot get ID, and I can just provide I can put whatever value I need inside the cache. So this is one way of managing the cache using programmatically, and another way is to use annotation driven approach using the annotations. So as in our case, it's just enough to use annotations, so I'm just going to remove this particular code. But if at all you need more control, you can use cache manager. So I'm just going to clean up because we don't need this cache manager. So that's it with the implementation of the cache. In the next section, we are going to see how to write an integration test for this particular setup. So I'm inside the Spring Boot Redis cache application test class. And I've already returned the integration test. So I'm just going to explain how we can go about integration testing this cache mechanism in our Spring Boot applications. You can find the source code inside the main branch of the GitHub repository. So you can see that we are using test containers to make sure that we run our integration test against a real Redis instance. We are not going to use any in-memory embedded Redis libraries, but we are just going to make use of the actual Redis server. So you can see that we have the Spring Boot test annotation and the test containers annotation. We also have the auto configure mock MVC annotation, as we are going to make use of mock MVC to make calls to our controller endpoints. So here we have our Redis container that is configured to run for our integration test, and here we have the service connection annotation. So what this annotation is going to do is it's going to make sure to bind the connection properties of this Redis container to the Spring Data Redis host and Spring Data Redis port properties, right? So before the use of Redis service connection annotation, we used to manually map the port and host properties inside our integration test, but by adding this service connection annotation, we don't need to do this anymore, and it is done out of the box. So next we have our mock MVC product repository and cache manager annotations auto-wired inside our test. We also have a spy bean annotation for our product repository. I'm going to explain shortly why we are using a spy bean here instead of using actual bean. And we also have an object mapper configured for our test. And inside the before each section, we're actually making sure to clean up the database because we want to work with a clean state of database for each test. So that's why we are deleting all the products from the database. And the first test we have is for the create product and and we have to check if it is cached or not. So for that, I'm going to create a new DTO called with the product name as laptop, and the value is going to be $1,200. And I'm going to make a post call using mock MVC to the /API/product endpoint. And I'm going to expect that the product creation goes well, and it'll return us a created response, right? So that means a 201 response from the endpoint. Once this is done, I'm going to get the product ID and check if this is existing in the database. And lastly, I'm going to also check if this value is existing in the cache or not. So here you can see that to get the values from the cache, we are using the cache manager annotation I showed you some time back. So here you can manually get the cache and check if the values are existing or not. So you can see that they are using assert not null annotation to make sure that the cache entry is existing with this given product ID. So the next test is going to be interesting. So here we have the test get product and verify cache test. So here we are also making sure to save the product in the database first. So we are going to save a product called as phone with the price as $800, and we are going to save it in the database, and we are making sure to call the get endpoint. So I'm going to pass in the product ID, and I'm going to do an assertion that the request is successful, and I'm also going to do an assertion that the endpoint is returning the expected product as a response or not. And here is the interesting thing we are doing. We are using a spy bean instead of the actual bean for product repository. So let me explain what is a spy. So a spy is a unique component used in testing. Spy can be considered as a partial mock. So using a spy, you can verify the interactions with this particular bean. So in this case, what we want to do is whenever this get endpoint is called, we want to make sure that the product repository.findID method is not called. Right, so that's what we are going to do. So using a spy bean, we can make sure we can, as the name suggests, we can spy on whatever interactions that are made on the product repository bean. So here, as we are making a get endpoint call, we are verifying that the product repository.findById method is called exactly once. And in the next step, we are clearing all the invocations that are made on the product repository spy bean. Right, because in the next step we are going to make a call to the API get product endpoint, and this time the product repository.findById method should not be called, because if you remember, so just to go back, here we have our cacheable annotation that is going to do a lookup based on the product ID and is going to return the product DTO from the cache. So in this case, it's not call the product repository.findById method, should not go to the database to fetch the result. So that's what we are actually verifying here, to make sure you are making use of a spy to make sure that there are no interactions on the product repository bean. I'm not a big fan of using this mock bean and spy bean annotations. No, Mockito spy bean and Mockito mock bean annotations. Don't use it frequently. Only use this in some unique cases, because if you use this mock bean annotation and mock spy bean annotation frequently in your test suite, then the Spring Boot will not use the application context, and it will create a new application context whenever it finds this mock spy bean or mock bean annotation. So next we have the test update product and verify cache test. So this is going to it's very similar to the create product test. So first we are going to create and save a product, and then we are going to make a call to update the product with a new product name and price. And finally, we are going to also verify that these new values are updated in the cache. And next, and the final test we have is the test delete product and evict cache functionality. So we're going to first make sure to create and save a product in the database, and we are going to call the delete endpoint. And finally, we are going to check that this product is really deleted from the database by making sure that this product repository.findById method is returning an empty optional. And finally, we are also making sure that we are returning a null value when we do this cache.get call, cache.get method call. So this is how you can write an integration test to verify the cache functionality. I hope this is helpful to you, because you don't find this kind of in-depth explanation about caching and how to write integration test in any other YouTube tutorial. If you have any feedback, let me know in the comment section. I will see you in the next video. Until then, happy coding techies.